So as I was saying, who doesn't love bread, right? I love bread, and a loaf of bread falls in this category because it has a 1 kilogram CO2 equivalent when it's an 800 gram loaf. Bread is good stuff. A year's calorific intake can be had for around half a ton of CO2 equivalent. That's only 5% of the 10-ton lifestyle and 1/6 of the current UK diet. So culturally it's been very important. In India, the bread is consumed mostly as rotis and chapatis and naans and so on, whereas the French love their baguette, and everybody must wake up and walk to the local bakery and walk back with a loaf of the baguette. And generally, US prefers sliced bread, which is sold by huge chunks by the supermarket. Sometimes you can also buy frozen bread, or you can take it home and freeze. So while by itself a loaf of bread is not too bad in terms of carbon footprint, the biggest problem of bread turns out that it tends to get wasted a lot. Sometimes almost 50% of the bread from a package you buy could be wasted, either chopped off at the edges because some kids will not eat it, some restaurants don't want to serve a sandwich with a crust, and so on and so forth. So footprint of the bread at the supermarket checkout, ingredients of course make up most of it. The supermarket adds about 11%. Transport of the bread is about 14%, could include ingredient transports as well. Bread bag, typically it's in a bag, depending on where you buy it. Could be plastic for sliced bread, or a paper bag for a baguette in France, and so on. Or many French just walk with baguette in hand without any bag. Baking, 17%, which is using a lot of energy, of course. But bread, waste of bread, it's a big problem. So this is from this website on Eco and Beyond. Toast Pale Ale, what is it doing? Wants to end the food waste. So brewed in a bakery, they have the Toast Pale Ale, UK's first bread to beer ale. So they are not wasting bread, they are converting it into pale ale. So they are 15 million tons of food waste in the UK. Bread is the worst offender. The amount of bakery good thrown away is enough to lift 26 million out of malnutrition. Just imagine that, okay? 24 million slices of bread are thrown away by households just in the UK. 24 million slices. 44% of all bread produced in the UK is thrown away. UK food and drink waste is 20% of the carbon CO2 equivalent. An area the size of Wales is used to produce food and drink that ends up going to waste. In general, food waste is a big problem across all countries, including developing countries or poor countries. Toast Pale Ale brewing process gathers surplus bread from delis, bakeries, and sandwich makers. It slices them, mashes them into breadcrumbs, brews with malted barley, hops, and yeast, and bottles them, and then gives you to drink and enjoy. Of course, then we have the issue of bottles versus cans and the taste and so on and so forth. But there are also sites like this, the food bloggers of Canada.com, which gives you tips for preventing food waste with breads and grains, and how you can refrigerate them and use them later, make them bread pudding or salads, croutons, and so on and so forth, right? If you pay attention, you can actually reduce bread waste. So it's not so much the CO2 equivalent of the bread itself, but how much waste is being created. A bottle of wine, again, 400 grams CO2 equivalent from a carton with few road miles. So here we are again getting into this debate about whether wine really tastes better from a bottle or a carton. The French were very averse to the carton that you could buy from California vintners, for example. They would look down upon it. But on average, now you have more than a kilo, 1040 grams of CO2 equivalent for a bottle of wine, 1500 grams if it is over elaborate bottles transported for thousands of miles by road, which happens a lot. For example, the European wine may be received on the east coast of the US and then shipped to the interior by trucks and trains. Okay, so that's going to add significant amount of carbon footprint as well. So if you drink 3 bottles of typical wine per week, which is pushing the limits of a healthy lifestyle, that's about 150 kilograms per year, equivalent to driving 210 miles in an average car. So I love my wine, I enjoy wines, but I obviously don't drink, well, I'm telling you, I don't drink 3 bottles in a typical week, except when we are having some get-togethers or whatever. But that obviously gets modulated by because you drink less for a few days and so on. So wine is another thing, but the carbon footprint of a bottle of wine in grams CO2 equivalent comes from growing grapes and turning them into wine. Glass bottles, which we already saw, is a process of producing it and transporting it. It weighs heavy, so it's a big problem. And it's not recycled as well as cans and cartons are. Transport by road can add a lot. Storage, proper temperature, the French love their wine at a certain temperature, red wine and white wine. Transport by ship is much smaller than transport by road, of course, so these things have to be kept in mind. Let's revisit plastic. We looked at plastic before, including plastic pollution, but here we are coming back to it in this range of 1 to 10 kilograms. 0.75 kilograms if you are using a eco sheet, which is recycled plastic made into various products that can be used for roofs and mats and carpets and various other parts of bicycles and so on, I suppose. But it's not completely clear if this is really a life cycle analysis calculation or not. This is for one particular company from the UK that the book reports. It jumps to 1.7 kilograms of CO2 equivalent for polyethylene tetraphthalate or some such thing, PET, for plastic bottles from recycled materials. 3.4 kilograms CO2 equivalent for polystyrene from virgin materials. 3.5 kilograms on average for when you combine all the plastics that is around. 4.4 kilograms of CO2 equivalent for polypropylene for injection molding made from virgin materials. So depends on what is being made and what process is being used and how much energy is going into that as well. Injection molding requires temperatures, liquefying, drying, etc. 9.1 kilograms, quite a big jump, CO2 equivalent for some types of nylons. Okay, so PET here, this company argues that PET is transparent, reclosable, and can be designed to be reusable with added advantages of being shatterproof. It's infinitely recyclable if you are so inclined. PET bottles drive big transportation savings, 1.5 to 2 times per truck more than glass bottles. That's the easy one for grasping. PET bottles have up to 70% less greenhouse gas emissions than other packaging types. Producers less product waste due to its resistance to breakage and denting. 90% of PET in the US that goes into recycling bin is recycled again. Okay, so you have to worry about what the existing technologies and chemical recyclings are, and this is compared to aluminum cans and glasses. So the relative savings are also important. But in general, plastic is still something that we have to worry about in terms of where it's going to end up. One way is to think that it doesn't biodegrade and produce methane like non-plastic waste. So it's just hydrocarbon going back into the ground and can stay there for long. How long? that we discussed before can be causing lots of other problems like breaking down into microplastics, getting into the groundwater system, into the rivers, into the oceans, into the fish, and affecting productivity of the ocean overall and polluting on average. We don't even know what other climate impacts it has in terms of the ability of the ocean to take up carbon dioxide and heat, and so on. But plastic is something that is a miracle substance and is going to be around for a long time. So recycling has to get better. Manufacturing processes have to get better. Recyclability also has to get better. Biodegradability is a complicated factor because even a PET, which is argued to be so good, often is coated with materials that make it biodegrade slowly or not biodegrade, or even make other things in the landfill biodegrade slower than their usual rates because of these chemicals. So even the so-called bioplastics that are supposed to be biodegradable, like corn plastics, often are coated with things that make them not biodegrade or biodegrade so slowly that it's hard to call them biodegradable. So many countries are placing rules on calling things biodegradable when they are plastic. So you have to be careful about those as well. Okay?